Very much. Can everyone hear me okay in the back? Yeah, okay, lots of thumbs up, that's great. Yeah, I'm Nigel Talbot, experimental test pilot with Leonardo helicopters. My background is originally a military pilot, flying lots of single-engine helicopters with doing single-engine IMC, IFR. IMC and IFR, that's an important differentiation. IFR is easy, IMC is not necessarily easy, but from that beginning test pilot course, test pilot military duties, then UK Civil Aviation Authority, and I had the pleasure of working with John Vincent on many occasions, and doing certification work on all types and also regulatory development work. I was then seduced into Leonardo helicopters to be an experimental test pilot, and I've done a lot of different things there, including more recently back into single-engine aircraft in the form of the 119, which has been very interesting. Yeah, so that's just our general title slide. A summary of what I'm going to talk about today is just an abstract. A little bit of history. How do we get towards single-engine IFR, IMC? What the impact from a regulatory point of view might be, and then a few conclusions. We, of course, or I'm speaking today in the context that we, Leonardo, have just certificated a single-engine aircraft for IMC IFR flight in the States. And this is the first one for some considerable time. And this is a potential opportunity for safer and more robust light aircraft rotorcraft design, safer operations compared to VFR operations, which typically are done by single-engine helicopters. The obvious safety benefit of if you have a good IFR IMC capability, you can deal with inadvertent flight in IMC. And pilot training, of course, is absolutely fundamental to this whole process. So there are opportunities there, and our purpose is to explore in the future, the near future, the possibilities of expanding within Europe into the concept of single-engine IMC IFR. A little bit of history. The 1970s, helicopters started flying more and more in IMC conditions. IFR became more common. A lot of this sort of activity in oil and gas support offshore. Most flights, for example, in the North Sea are carried out under IFR, and IMC, fly in a cloud, it doesn't matter, unless there's icing there, of course, which is another subject. But the stringency of the requirements started to increase, and John Vincent's lead into this was very relevant. The requirements, if you like, are a compendium of the disasters of the past. And there's always a basis for a requirement, but they did become more severe in relation to system safety assessment and so on. And in 1999, 2003, and this effectively squeezed single-engine aircraft out of the IMC IFR world. On the basis that the available technologies didn't really fit in with the lower cost concept of single-engine aircraft. So really the concept sort of died away for quite some time. But of course, during that period, the single-engine or helicopters in general have increased their level of capability quite significantly. But almost all the activity that's done in helicopters is done VFR, VMC, with the exceptions of places like some of the oil and gas operations. I mean, for example, we have most of our twin-engine IFR-capable aircraft do not do IFR. So there's something of an issue there, I think. Clearly, this use of VFR, VMC, when you do have an IFR capability, is sort of counter safety. And you can see that there's a significant number of accidents caused by flight inadvertent IMC, scud running, all the famous things which cause problems for helicopters doing VFR, VMC type operations. But however, there's a point to be made in there that even with IFR capable helicopters, you still have accidents, and it's in a move to increase the amount of IFR, IMC that's done. You may reduce some of the VFR, inadvertent IMC, scud running type accidents, but you still have the possibility of IMC, IFR accidents with capable aircraft. So there's not a total cure to this by, for example, changing engine configuration is not necessarily going to influence the statistics. So we need to approach that one from different directions. In the US, the industry petitioned the FAA to change the methodology of certification in the paper that they wrote in relation to single engine IFR certification. And the FAA did respond to that, issuing the safety continuum concept for Part 27 normal category rotorcraft. And this process resulted in the certification that we achieved quite recently with the 119 for the US Navy TH-119 training aircraft. Obviously, there is activity going on now within Europe, which we're very happy about in terms of enhancement to the safety assessment process, and John Vincent mentioned that. And we believe that this is a very helpful process that's going on at the moment. And of course, as I've already mentioned, single engine IMC is a reality again, but in the US, not currently in Europe. So can we exploit this situation to improve safety? Well, the improvement in safety, the datum is obviously current VMC, VFR operations, not necessarily twin engine IFR operations. How do we get there? Well, there are three key issues. There's design, operations, and training. And this is the Leonardo perspective on the situation, that we should have improved and reliable design, and that is perhaps in relation to what might be considered the standard of single engine aircraft currently. New operational scenarios and infrastructure, of course, is the key, the absolute key to all of this. Training is vital. We have to maintain or increase the competency and capability of pilots to operate in IMC IFR. And there can't be any reduction in standard. The engine configuration has no influence whatsoever on the need for pilot training, so you can't compromise there. But it does need to be cheaper. Can we find a cheaper way of doing it? And if we are trying to create an environment in which people are thinking of IFR operations instead of doing VFR all the time, then training is absolutely vital, and in terms of shifting the way people think about doing their operations. From a design point of view, this is an opportunity to take the cheaper basic architecture of a single engine aircraft and the lower operating costs, but not necessarily to take all the advantage and come up with a compromise between the reduced cost and availability of and hence increased availability of a single engine aircraft, but take into account some of the parameters and the features that exist already for IFR aircraft, and again thinking to system safety assessment processes. And so this is our view of life, of the current situation in single engine VFR helicopters. In terms of navigation aids and GPS, then obviously maybe we shouldn't have put a cross against that one for existing aircraft, because quite a few are equipped with reasonable nav systems. But for us, a candidate single engine IFR aircraft would have features such as redundant flight stability augmentation, redundant attitude sensors, airspeed, barometric altitude, and also power generation is important. Do you really want to be in a cloud relying purely on a single system? And the same with hydraulics. The flying control failures can leave you in quite a poor position in terms of stability and control of the aircraft, and maybe that's a failure you don't really want to have when you're IMC. And EMI protection is also a significant one. In terms of operations, and if we do have robust helicopters that people have a good confidence in, it will increase the tendency to use them for more demanding operations. But there needs to be a very, very careful reevaluation of the operational rules to create as a part of the process of creating the IFR infrastructure. And the concept of all-weather operations, of course, is very important. And also the engine failure criteria need to be assessed. That's a biggie. Currently in the operating rules for single-engine aircraft, you have to be able to carry out a safe landing in the event of an engine failure. That becomes more problematic with IMC, IFR type operations. So that will need some work from a regulatory point of view and on the operations side. The all-weather operations, I'll say a little bit more about that on the next slide, but we need to consider whether commercial air transport can be used in IFR in congested environments, and obviously to develop as much as possible PBN, RMP type operations. So we need to make the whole thing more accessible to the industry to get the safety benefit of IFR operations. The infrastructure, it has to improve. We have many IFR capable aircraft not doing IFR. Why? Because it's really difficult to do IFR operations in a helicopter. And things like low-level IFR routes, approach methodologies. And approach is an interesting one, because typically for an approach to an aviation facility, such as an airfield or possibly to a hospital site with an established LPV approach, you have visibility and cloud-based requirements, and they need to be defined to be able to carry out a safe approach. And if you are doing this type of approach to non-airfields, you need to consider what the minima are that you achieve in the approach. If you have to have 1,500-foot cloud base, for example, for obstacle reasons, then probably you're not going to use IFR very much, because you've always got a good VFR route underneath the cloud. So it's important to try and define and come up with some good and useful limitations. And the other big difficulty is remote sites. If you're going to try and deploy your helicopter, say on an EMS mission, to a grid reference, a crossroads somewhere that you've never been to before, how do you make an approach to that? How do you know what the weather is in that location? So these are sort of barriers to use of IFR. And there are interesting operational developments, and perhaps there are ways around this with better infrastructure. But it needs quite a lot of work to give access to IFR operations, which is not dependent upon engine configuration. So we need to work together to try and move in this direction. Training, absolutely vital. There have been too many examples of apparently adequately trained pilots in IFR-capable aircraft flying into the sea, flying into terrain, losing control of the aircraft. The level of training and competency that comes out of basic training and qualification for licensing is not always adequate. So if we start doing much more IMC IFR activity, we expose ourselves to that risk. And it's absolutely vital that training is made more accessible and is made cheaper. And the benefits are that it would, if we can achieve this, it will increase the proficiency of crews in general and enhance safety in a significant way. The route forward has to be, in terms of modern technology, reducing the cost of training. And at the moment, it's very expensive. People are reluctant to spend the money on it because the benefits of training the crews are very limited because the infrastructure is not there, et cetera, et cetera. The whole thing goes together. And so we have to think about how we can make the IFR rating more accessible to pilots. And there are many technological solutions around. Virtual reality simulators, for example. There are some examples in the on the other side of the atrium here, which in my opinion, show great promise in terms of giving low-cost training of high quality. But what we must not do is compromise the quality and the skills of the pilots. We need to increase them. So if we do succeed with this venture, then we can end up with a situation where we have improved design, which is nevertheless a cheaper product to operate, to own and operate. We can open up a new world of operations, single engine IFR, rotorcraft, avoiding the perils of VFR, scud running, inadvertent IMC, etc. The infrastructure has to come into place, otherwise it's not going to happen. And we can have more skilled and proficient crews who think about flying in a different way. And in the end result of this can be reduced VFR accidents or reduced accidents compared to conventional VFR operations. So there's a prize there to be had. Thinking a little bit about the rules, the FAA environment, we know what's happened there, and there has been the push with the safety continuum to make it easier to certificate aircraft, to give capabilities that will reduce operational problems. We need to be careful we don't reduce the certification standards and the basic airworthiness of the aircraft too far. But the concepts of proportionality and safety continuum are relevant and need to be taken into account. And of course, in the EASA environment, we have the activity of the rulemaking task going on at the moment, which we strongly support and we think will be very beneficial. It is possible to certificate now, but the criteria are quite severe. So I think the rulemaking activity does need to progress to move us towards a situation where we can achieve single engine IMC. Flight crew licensing rules, no need for change as far as we can see. And just to emphasize again that we don't need more qualifications, but we certainly don't want to reduce standards. Operation rules, this is a more difficult area perhaps, because the basic rules as they are make it very difficult to consider single engine IMC. So that needs work done on that to consider the various options that could come forward. And I mentioned already the engine failure case, and we have to find a way of working on that. Again, if that leads to, for example, a cloud base to give you some maneuvering space to carry out a landing, then you defeat the benefits of IMC if you always have to have good enough weather. So there needs to be consideration of the relative risks of engine failure versus the operational procedures or the operational risks that you're removing by facilitating this type of operation. So this is an important area, and we of course as a company are very happy to work with EASA and other stakeholders to move in this direction. So a few conclusions. For us, certification for IFR for single engine aircraft means new operational capabilities, which will result in a safety benefit. It's absolutely essential to make training available that is cheaper, more accessible, more accurate, and more frequent. We cannot compromise, otherwise we'll just translate the VFR accident problem into an IFR accident problem. The crews must be capable and competent. Design, we believe there's an opportunity to improve designs and come up with a safety standard that is acceptable from an airworthiness point of view, but also facilitates single engine operation. And there are a push there to improve the equipment standards on board the aircraft. So single-engine IFR helicopter can improve the technology, system redundancy, and design reliability. If we take that approach, we can increase mission capability and performance, which is a good thing for everyone. Training, single-engine IFR helicopters are now very useful for training as a lower cost route into training for more expensive aircraft, and that's what the TH-119 is doing for the US Navy. It's their lead-in training aircraft, so it can certainly help in safety by making single-engine IMC IFR training more available to everyone. And can we come up with a concept of light IFR? Yes, it's a nice concept, but it has to be approached very carefully in all of the aspects which I've talked about. The way forward to complete a certification or a validation with EASA for a single-engine IMC aircraft and work through all of the discussions, the issues, the potential rulemaking implications of that, and obviously work towards IFR training light in terms of cost and availability, not in terms of quality and standard, and then explore and exploit the benefits of a capability to fly in IMC with single-engine aircraft. Okay, there's contacts myself and Emanuele Bufano within the company, and we're open for any further discussion on the subject that anyone might like. And thank you very much indeed for your attention today. Thank you.